G'day Hammerheads, welcome to the backyard. So today we're going to be taking a look at a great Aussie tradition of making your own bolts. Specifically these guys, which is a 10mm U-bolt. Now if you've ever climbed in the sandstone country of Blue Mountains and Nowra down in New South Wales, you definitely would have clipped a whole bunch of these. But you probably had no idea what was actually beneath the rock. So I have a whole bunch that was sent to me by a guy down south. So g'day Dave, cheers for that. Now this is 10mm bar stock. I'm not at all worried about the strength of the steel itself, but more interested in the shaft preparation. So not sure how well you can see that, but it's been notched all along there. And some of these bolts are slightly different, so it's obviously done by hand. You can see the notches on there a little bit better. So really that's what we're going to be looking at today. I don't expect the steel to be failing at all, but I am interested in seeing how well the glue sticks to a shaft that's been hand ground like that. So as you can see, I've got a bit of concrete and a bit of pretty hard sandstone. So I'll install one in each of these blocks, and then in about an hour we'll be able to pull them out and see how well the glue actually sticks in there. Dave's done a really good job of getting the dimensions the same. So really nicely done there, mate. But the notching is all a little bit different. So I reckon I'll take this one, which is like the smoothest. I'm going to put that in the sandstone. So that's going to be a kind of, not your worst case scenario, but you know, not a very good scenario. And then let's try and find a really nice, well, that one's very deep. Let's go this one in the concrete, and that is 32 MPa concrete. Not sure about the sandstone, but it's probably about the same. And joining us today is the new Makita 40 volt mini rotary hammer. So very nice little unit, that one. And I'm going to use some DeWalt vinyl ester glue. So that's AC100. So I've never actually used this style of bolt in anger. Okay, so this one will fit nicely in the middle there. And nope. So that is obviously a skill you're going to have to practice a lot when you're installing these guys. But I guess also if you are working like overhead, you're going to have room to actually diverge those holes a little bit so that you maybe have to hammer this thing in and then the metal will actually pinch there, and that way while you're waiting for your glue to harden, they're not going to fall out. So that's one plus of these things. And you've obviously noticed by now that for each one of these bolts you've got to drill 2 holes, so double the drilling and also double the gluing, which is, I've never bothered with these things. Okay, so sandstone. Okay, I'm getting better at this. So another quirk I've just noticed with these guys is you've got to be a little bespoke with your drilling. So this is the one I measured the depth with. And then this is another one. So in the case of these things, you've got to make sure either your bolts are really consistent, really nicely all the same, or basically drill and match each bolt to the hole, or I guess bring a hammer and whack those in if they're not really cooperating. Now this is the one I wanted to use. Okay, nice, good. Whoop. Okay, let's set the glue using this multi-canister gun, which is really nice. Okay, ready to go, here she comes. Now, discard just over here. 2, 3, and then I'll do our before sample just there. So I'm using this vinyl ester glue because it's not as strong as epoxy. So again, it should reflect a kind of worst case scenario, like a not as good case scenario. Okay, so you can't rotate it, you've got to basically just stick it in. I guess a little bit of side to side movement. There's plenty of pressure in there that's going to be forcing the glue into all those little cracks. That one has a bit more room, so that'll be getting it in there nicely. I'm not too worried about the glue actually getting into the cracks if we're not turning it, because there's quite a lot of pressure there. All right, well, we'll leave them for an hour or so and see how it goes. All right, so you're probably wondering why the hell people bother making their own bloody U-bolts like this. Well, the answer is they're cheap. You can make these for probably less than $2 each. Because if you get bar stock, if you find a good supplier, you can get, 10 mil stainless bar stock for maybe $8 a meter, and you can get around 5 bolts per meter. So yeah, these will work out to $2 or less a piece. Contrast that to standard ring bolts. These guys are more like, well, cheapest I can get them for is about $8 each. So minimum 8, more like 10, $12 each. Then if you're getting into something like this, more like 12, $14 each. And then a big guy like that, often, 15, 16, look, it adds up, And U-bolts like this are mainly used in sandstone, so the rock's pretty soft, so you do need a big bomber bolt. But also in the Blue Mountains in Australia, and yes, I know they are orange, the cliffs are really big, several hundred meters, so you're looking at many pitches. $15 a pop times 100 is a hell of a lot of money. So down there, they've just worked out that this is a cost-effective way to do really good, strong bolts. And so this is 10 millimeter bar stock, it's just got more bends. So this and this are basically equivalent. The other thing is, if you got 2 of them, stick them in like that, that is a wrap station already. You don't need any more hardware. This is 10 millimeters, fine to run ropes through. But of course, these guys do take 2 holes. So that's twice the drilling, twice the cleaning, twice the gluing, twice the time. So I'm not a big fan of them. Something that is more common up here is the machine bolt. So you basically get a threaded bolt like that, and then you basically glue that right in. If you have epoxy underneath the hanger, that'll sit pretty nicely and it should never really turn. Alternately, you can get threaded rod by the meter. You can cut it to whatever length you want. A little bit more expensive, a little bit more work, but then because you do need to have a nut and a washer on there. But the advantage is if that ever comes loose, you can then tighten it up and stop it from spinning in future. If you ever need a super long bolt for whatever reason, just get a meter of threaded rod, cut it to length. But anyway, let's head back out and see how you actually do this cool notching. So I want to test the glue. I don't really want the rock breaking or anything like that. I guess it can, but really the glue, the metal sticking to the glue is what we're actually testing here. So doing a bit of a confined pull, and I just have these bricks where they're going to sit flat. I've got my newer system going on. This is a hollow ram. I'll stick a bolt through there, but yeah, I just wanted to show you the newer setup. I've actually used this quite a lot, but I haven't actually published anything yet. All right. Let's pull it. 290 kilograms per square centimeter. So in this particular ram, that pressure, 50 kilonewtons. 50. Hasn't done a goddamn thing. Oh, there we go. 298, so 50-ish kilonewtons. So as you can see, the glue got into the little crevices nicely, and it's still stuck to the steel. So your glue to steel bond, good as gold. Okay, so here goes the concrete. Hey, rats. Look at that. Alright guys, so 35 kilonewtons or so, and 50. Oh my lord, I cannot believe it. So I'm super stoked with these results. The main question we wanted answered was, does the glue actually stick in these notches that are just being like done by hand? And yes, it sure as hell does. So as this one was pulling out, you could hear it go pop, pop, pop. That was the glue shearing off there. On this side, the bond between the glue and the metal was actually stronger than the glue and the concrete, which is what this stuff is actually designed for. So really impressive. And this is just a vinyl ester, not an epoxy. Now on the sandstone, I'm assuming that's the shorter side and the longer side stayed in there. So this actually was a fair bit stronger because the rock was stronger than the concrete. Now if you remember my Schmidt-Hammer video where I tried to estimate how strong this sandstone was, I'm sure you guys all watched that. This stone came up to about 40 or 50 MPa, and this concrete was 32 MPa. I had it made specifically to be, strong enough to handle this kind of stuff. So that is awesome news for me. The sandstone is stronger than the concrete. The concrete is a known quantity, and, seems the Schmidt-Hammer estimates were true. This was a lot stronger than this. As always, the question is this strong enough to climb on? And the answer is shit, yeah. So nicely done. Guess you can breathe a little easier, Bluey's climbers. All right, frothers, well, I am pretty stoked with this result, and I bet all those Bluey's climbers and Narrow climbers, they're even more stoked, because this is potentially the most common style of bolt in a lot of Australia. So it's good to know that even with not the best glue in, not the best rock, she's still bomber as. So I'm very stoked to see these results, and I bet all you Bluey's climbers and Narrow climbers are even more stoked, because this stuff probably not going anywhere unless you use really shit glue. This kind of steel, I would expect at least 55 kilonewtons out of one length of steel, so that's 10 millimeter rod. So about 55 kilonewtons, theoretically about 100-ish for something like that, assuming your substrate doesn't break, your glue doesn't break, all that stuff. Realistically, with one of these, unless it's corroded, the steel is going to be the strongest part about it. And so I did a confined pull, so I really wanted to try and focus all the force on the glue, but still the substrate broke in both cases. So in this case, it was crushing in between the holes. In this case, we had one leg pop out, and that was the shorter leg. So it seems like the forces were pretty evenly distributed. It couldn't crush the rock in between, and she popped out on the weaker side, basically. So good to see. So anyway, frothers, good stuff. Glad to see my new bigger ram is working out nicely too. So there you go. Thanks to Dave for sending these up for me too. I'm going to start playing around with a little bit more of this sort of stuff when I get time. Because hey, who doesn't like to save a buck and also be, pretty damn safe on the wall? Anyway, thanks for watching. I'll scratch you later.